Hello everyone. So we are going to start the discussion on two basic diseases which are associated with the metabolism of amino acids. So these two diseases are the Alkeptonuria and the Tyrosinemia. So starting with the Alkeptonuria, so let's have a breakdown. So this disease, it is also known as the black urine disease. So the patient suffering from this disease, they generally produce the black or dark colored urine, first of all. Moreover, it is an inherited genetic disorder of the phenylalanine and tyrosine metabolism. So these are the three most important things regarding this disease. Now, a condition which develop in this disease, it is the ochronosis. Ochronosis is nothing but ochronosis is generally considered as a build-up, a condition where building up of dark pigments is occur in the connective tissue such as cartilage, skin, and it is also characteristic of this disorder. So dark color urine, moreover it is a genetic disorder in the metabolism of the two amino acid phenylalanine and tyrosine. Moreover, the ochronosis. These are the three most commonly occurring symptoms in the Alkeptonuria. So what is the causes? The cause is nothing but it is generally the mutation in the HGD gene. So we are going to discuss in details regarding this mutation. First of all, the gene defect that makes the body unable, this particular gene defect, it makes the body to unable to properly break down the amino acid tyrosine and phenylalanine. Because of this mutation, the tyrosine and phenylalanine, they don't get completely metabolized in the human body. Moreover, as a result of which, a substance called, we have already discussed regarding this thing, a substance known as the homogentic acid, it builds up in the skin and other body tissue. So now what actually happens? Now these acids, the homogentic acid, whatever it has formed or built up in the body, it comes out from the body through the urine. And once this acid it is coming out from the body via the urine, once this acid it reaches the atmosphere, it get oxidized and thus make the color of the urine brownish black. So if we continue with the discussion, first of all, you see it is caused by the mutation in the HGD gene for the enzyme, a specific enzyme. It means a specific gene, the HGD gene, it is mutated, and because of which the enzyme it get affected. The enzyme, it is nothing but the homogentisate 1,2 dioxygenase. It is the enzyme which get affected. Now if a person, if he inherits abnormal copies from each of their parents, it is in the recessive condition. Suppose from the mother is a carrier, even the father is a carrier, then the body accumulates an intermediate substance in the other person accumulates a substance which is known as the homogentic acid in the blood and the tissue, right? Now this homogentic acid, it is the intermediate in the degradation pathway of the phenylalanine, regarding which we have already discussed in our previous slide, right? So this reaction, it is catalyzed by the homogentisate dioxygenase. This is the particular enzyme. So this is the homogentic acid, this is the HGO. So this is homogentisate dioxygenase. Now this will finally lead to the conversion of the homogentic acid into the mallyl acetic acid, the mallyl acetoacetic acid. So this conversion, it don't takes place actually in this disease, right? Now this mutation in the HGD gene causes the Alkeptonuria. We have come to know that, right? So let's have far more discussion regarding this. So this HGD gene actually provides the instruction for making the enzyme. This enzyme is known as the homogentisate oxidase, right? This gene HGD is responsible for production of the enzyme known as the homogentisate oxidase, right? Now this enzyme actually, it helps in the breakdown of the phenylalanine and tyrosine. How they are going to break it down? Because we know that the phenylalanine, it get converted into tyrosine, and this tyrosine finally get converted into homogentic acid, right? So once this homogentisate oxidase it is affected, it is indirectly affecting the metabolism of phenylalanine as well as the tyrosine. And we know that these two, the phenylalanine and the tyrosine, these are the important building block of different proteins which are associated in the human body, right? Now mutation in the HGD gene actually it impairs the enzyme role in this process. We have already discussed. So this mutation led to this particular condition. Moreover, as a result of which the substance which is known as the homogentic acid, it is produced from the metabolism of phenylalanine and tyrosine. It actually accumulates in the body, right? So this homogentic acid, it accumulates in the body and it comes out from the body via the urine. So excess of this homogentic acid and related compounds are deposited in the connective tissue. Once the amount of the homogentic acid is increasing in the body, these are generally get deposited in the connective tissue, and this can lead to the causes of cartilage and skin to darken. The cartilage and the skin, it start darkening. Now what are the symptoms of this disease? So basically these are the symptoms we are going to discuss. So first of all is you see the urine in the infants, they turn almost black after several hours. So this is the urine, it get normal urine. This is the urine of a person suffering from alkeptonuria. So they turn black after certain hours, right? Moreover, sometimes what happens, this condition it don't comes out in most of the patients. So what happens if you are detected at a late age, suppose after the age of 40 or around the age of 40, then you may have some other problem apart from the urine. It means your body may not produce the black or dark urine, but you may have other problem associated with the joints, right? So arthritis, it is a very special type of the disorder which is associated with the alkeptonuria. The arthritis especially it occurs in the spine in the patient who is suffering from alkeptonuria. Moreover, darkening of the ear, you can see here that ear it becomes dark, the color of the ear it becomes darkened due to the, as we know that it is the ear it is made of the cartilage. Here the deposition of the homogentic acid it takes place, it becomes dark, right? Moreover, you will find the patient may develop dark spots in the white of the eye. In this portion you can see dark spots he may develop, even sometimes in the cornea. So now how we are going to examine the patient and what is the treatment you can give to the patient. So first of all, you see urine test, it is the most commonly used, that is urine analysis. It is done for detection of the alkeptonuria. So simply you just need to give the ferric chloride. When the ferric chloride is added to the urine of the person who is suffering from the alkeptonuria, the urine it turns black within a few moments. This urine get turned black and you can thus confirm the person suffering from alkeptonuria. Now for treatment, see these all are genetic diseases. So for treatment you don't have any basic protocol, but generally you can give high dose of vitamin C. High dose of vitamin C, they have several beneficial action to the to the patient who are suffering from the alkeptonuria. Moreover, this has been shown to decrease if you give high amount of the vitamin C. It is actually decrease the buildup of the brown pigment in the cartilage, and also sometimes the high dose of vitamin C it slow down the process of development of arthritis of the spine in the patient suffering from alkeptonuria, right? The next disease is the tyrosinemia. So regarding the tyrosinemia, with the background, if we start, we know that the tyrosin it is basically obtained from the indigested protein, right? And it is produced or synthesized endogenously in the human body from the amino acid phenylalanine. We have already discussed regarding this. Now you see this tyrosin it is actually used for the protein synthesis, and it is a precursor. This tyrosin is a precursor for many components which are playing important role in the human body, like the dopamine, norepinephrine, epinephrine, melanin, and thyroxine, right? Now hypertyrosinemia, it is observed in 3 inherited disorder of the tyrosin metabolism. So this hypertyrosinemia it also have 3 different types. So let's discuss these 3 types. So if we start with the first type, it is the hereditary hereditary tyrosinemia type 1. It is nothing but it is a autosomal recessive disorder which is caused by actually the homozygous or compound heterozygous mutation in the enzyme in the gene which code what the mutation it takes place in the gene encoding fumaryl acetoacetate hydrolase This is the enzyme FAH. We have already discussed regarding the function of FAH in the metabolism, right? So if the mutation it takes place in the FAH gene, then the type 1 tyrosinemia it takes place. So the location of FAH gene, it is the 15q23 to q25. It is the location in the chromosome. The next one, it is the hereditary tyrosinemia type 2. It is a very rare autosomal recessive disorder. It is generally caused by the deficiency of tyrosine aminotransferase. This particular enzyme, it is deficient in this type of disease, tyrosine aminotransferase, so which acts in the first step of the tyrosine catabolism, right? The third type, it is the hereditary tyrosinemia type 3. It is even rarer, a very rare type of disease. It's generally caused by the deficiency of 4-hydroxyphenylpyruvate dioxygenase. This particular enzyme deficiency it takes place. Clear? Now you see that there is a causal relationship of high levels of the tyrosine with the disease state has been established only in the deficiency of tyrosine aminotransferase. So if you see, this is the overall pathway of the catabolism of phenylalanine. So this phenylalanine get converted to tyrosine, we know that. Then from here you get the 4-HPP, that is the 4-hydroxyphenylpyruvate, right? Forward you get phenyl acetate here. This is the overall chart. So this is, you see here the mallyl acetate. So these are the actual enzymes. These enzymes, they generally get affected with this type of disorder. So this is the overall chart. We have already discussed regarding this chart earlier, right? Now the deficiency of other enzymes involved in the tyrosine degradation, they cause little or no increase in the level of the tyrosine apart from the enzymes what we have discussed till now. So moreover to the enzyme whatever we have discussed till now, there is one more type, that is in addition to this 3 inherited disorder, there is one more type. This is known as the transient neonatal hypertyrosinemia. It is actually generally found in the premature infants, right? It is mostly caused by the immaturity of the enzyme. The enzyme, it is nothing but the tyrosine aminotransferase enzyme activity. If the tyrosine aminotransferase enzyme activity it is less, then the baby may suffer from neonatal hypertyrosinemia. And this type of screening it is generally done during the birth stage of any infant. Now this acquired hypertyrosinemia may occur in other conditions apart from this, such as hepatocellular dysfunction, liver dysfunction, if the person is suffering from scurvy, or even in case of the hyperthyroidism. This type of means you can say acquired hypertyrosinemia, it occurs in liver function, liver dysfunctions, scurvy, or even in case of the patient who is suffering from hyperthyroidism. So at last I am going to give you a slide here. You can easily identify the enzyme, the defect, and the major manifestation. So you see tyrosine aminotransferase. If the enzyme it is defected, the defect it can lead to the tyrosinemia type 2, and these are the major manifestation, which include the corneal thickening, developmental delay, hyperkeratosis. Even in case of the enzyme, if you have a problem with the enzyme, that is the 4-hydroxyphenylpyruvate dioxygenase, it can lead to the transient tyrosinemia of the newborn, which we have already discussed. These are their symptoms. Moreover, it can cause the Alkeptonuria. These are their symptoms. Even it can cause the tyrosinemia type 3. These are the symptoms. Apart from that, homogenetic oxidase, it can cause the Alkeptonuria. We have already discussed, which where the arthritis can develop, even dark urine can develop, and in the enzyme causes the mallyl acetate isomerase. It can also cause this defect Alkeptonuria. So these are their major manifestation. The last enzyme it is the fumarate acetoacetate hydroxylase. It can also cause the tyrosinemia type 1 or hepatorenal tyrosinemia, where these are the manifestations, the liver, renal, and neurologic disorder. So these are the overall summary of the tyrosinemia, or I can say the defects associated with the enzymes and their effect on the body. So lastly, thank you everyone. If you like the video, you can press the like icon. You can share this video with your classmates and colleagues, and for further notification from this channel, you can press the bell icon. Thank you once again.